All right, this is page 566, number 47, and in this problem, you've got to use some different hints you've got and put them together. First of all, you're given that there's an angle in standard position, and the sine of the angle theta is negative 5/13. So sine is negative. Automatically, I know that on the y-axis, I'm below x here. I'm below the x-axis line. So I'm either in quadrant 3 or 4. And then cosine is greater than 0, which is just a way of saying that cosine is positive, and so that means I'm to the right of the y-axis. So I've narrowed it down. This tells me it's either in quadrant 3 or 4. And now once I know that cosine is positive, then I can definitely narrow it down. It's got to be in quadrant 4. So I'm going to sketch a terminal side of an angle, just a given any angle in this quadrant, and build my little right triangle. And my theta will be right here in the wedge. And if the sine is negative 5/13, that means I go down by negative 5, and that my hypotenuse here is 13. So this is not drawn to scale, by the way, but I know that this would be a 5, 12, 13 Pythagorean triple. You can use Pythagorean theorem to find this missing leg, but I can tell that that is a positive 12 because I know that. So remember that in this quadrant, in quadrant 4, this is the positive x and negative y quadrant, so cosine will be positive and sine will be negative, as it is here. So given that the sine is negative 5/13, the cosecant is negative 13/5, and then the cosine of this angle would be 12/13. And so, because basically x is 12, y is negative 5, and r is 13. The hypotenuse is always positive. So this is y over r, this is x over r, so the secant would be the reciprocal of that, and then the tangent of this angle would be negative 5/12, and the cotangent would be the reciprocal of that, or negative 12/5. And that is number 47.